Hello everyone, this is Philosophy 2030 Logic with Vibo. Today I'll be going over Chapter 1, Section 4, Rules of Logic Reasoning. For definition, a rule is a particular form of argument, which may be used in extended reasoning. Certain rules involving negations and conditionals have been recognized for centuries, and they have traditional names. The basic rules used in this chapter are repetition, modus ponens, modus tollens, and double negation. Repetition goes with we have something. We have a battery, right? Ergo, we have a battery. It's just repeating what we said already, like an echo. Modus ponens, goes with if square, then circle, as we see here, if square, then circle, and we already have square. We can then use modus ponens to derive that we have circle as well. If square, then circle, and we already have square, we just pretty much input it within the system, and out comes circle. I'll use it with words. If Pat parks, then Rob runs. And we know that Pat does park, in fact park. We can come to the conclusion that Rob runs. Next we have modus tollens. For modus tollens, we have if square then circle. And we have circle does not happen, the negation of circle. Right here. We can then derive that while inputting into the system, out will come the negation of square. We do not have square. In the same example as earlier, if P then R, if Pat parks, then Rob runs, and we know that Rob does not run, we can then derive that Pat does not park. Lastly, double negation. It goes, we have something. This is something here, right? The statement, let's say it is Pat parks. We can say Pat parks, which is equivalent to Pat does not park, which is a double negation. It cancels each other out. The nots cancel each other out, and it's just as valid as it was prior. It doesn't really say anything new. It's just good for future learning. We'll get to it later. The same thing works around with if Pat does not park, as you see right here, then Pat parks. They just negate one another. Moving on. Let's do some work. If this is the statement right here, and it goes if P, then the negation of Q, and we're given just Q as itself, is that grounds to assume that P does not occur? Well, let's look at it. You cannot use MP because MP implies that the antecedent, the first part of the conditional, is in line with what you have alone, the Q. However, we can use Q to get the negation of P. How? Well, if we double negate the Q, it turns into the negation of Q, which, as we can tell through this right here, is one negation extra than the negation of Q in the consequence. If we plug in this right here for MT with this premise, this conditional, out comes the negation of P as a result. Ergo, MT. This right here goes, if the negation of P then Q, we can then conclude or derive that the negation of open bracket P then Q. This is false. This is nothing. Double negation, if we use double negation on this right here, it would be the double negation outside, negation of P then Q. Ergo, this is incorrect. the negation of a negation of open bracket P, if P, then Q. Close bracket. Using double negation on this, we'll just cancel out these negations, leaving us with this as a result. So this is fine, perfectly good. They use double negation. Moving on. If the negation of P, then the negation of Q, as is our premise, and we have the negation of P, as seen here, we derive the negation of Q. What rule is this? Well, modus ponens, MP. We plug in the negation of P on top, and it's the exact same values here to find the negation of Q as a result. If the negation of P, then the negation of Q is our premise, and we have the negation of a negation of Q, double negation, can we derive that we also have the negation of a negation of P? Well, yes, we can. Using modus tollens, plug into the statement on top, the premise here, and out comes the negation of whatever this is, because there's one negation extra than this, bringing us the result. If P, then Q, and we have the negation of R, can we derive the negation of P? Well, the premise did not state R wherever it was. Ergo, it's just wrong. There's nothing inferring that R is related to anything, there's nothing equivalent to R, it is just wrong. Alternatively, if the premise is, if P, then if R, then Q, and we have P, can we derive R then Q? Well, yes. We plug it in with MP, and out comes this, if R then Q. However, if the end of the statement, the negation of Q, in this conditional right here, was our second tense, our second use right here, premise 2 I'll call it, can we use modus tollens to derive negation of P? Well, no. Because we would require the negation of open brackets, R then Q, to be sufficient grounds of modus tollens to then derive negation of P. Right now, this is nothing. This is completely different than what's inside of here. So, lastly, if the double negation of P then Q, so negation, if open bracket, if P then Q is there and we have the negation of Q, how can we derive P then Q, if P then Q? Well, without looking at this right here, we know the rule of double negation is adding to or removing to negation signs. If we de-end this right here, we get the same answer. If we want to go one step further and use premise 2 right here, the negation of Q, in our statement here with modus tollens, we would then get negation of P, as we see from the equation right here. Now, to conclude, let's see what we can use on each statement. If the negation of W, then the negation of X is our first premise, and premise 2 is the negation of W, we can use MP to bring the negation of X. For B, if the negation of W brings up, if negation of W, then the negation of X, and we have the negation of a negation of X, double negation, we can use modus tollens to bring us the negation of a negation of W. If W then X, and we have the negation of W, can we use anything to derive anything? No. Because modus ponens does not work. Modus tollens does not work, because you do not have a negation of the consequence, nor do I have the straight form of the antecedent. Ergo, nothing. It's wrong. Nothing happens. Whoops. If W, then if R, then X, and we have W, we can use MP. Imagine it as triangle, then square, and we have triangle. We found we can then use it to get square, which is R then X. In the same light, if W, then if R, then X, and it's the negation of R. If the negation of R, then X, we actually cannot use modus tollens on this. Why? Because it's the negation of R. It's not the negation of the entire sentence that we are using right now. Premise 2, right here, PR2, is only if the negation of R, then X, not the negation of if R, then X. Ergo, nothing can happen. None. For F, we have if W, then X with 2 negations on the outside. And premise 2 goes, the negation of X. What can we do? Well, our first step is if we use double negation, it gets rid of these two, bringing us W, then X, if W, then X. With the negation of X right here, on premise 2, we can use modus tollens to bring us the negation of W. If W, then the negation of X, and we have just X, it may appear as though we can't do anything with this. We can't use MP, and we cannot immediately use MT, because we have one less negation sign in it. Instead, if we use double negation on the X, it brings us negation of the negation of X, which we can plug into premise 1 through modus tollens to bring us the negation of W. If the negation of W, then X, what can we conclude? Well, nothing really. If you wanted to use R, repetition, it will just repeat the sentence. But aside from that, that's all we got. You can use MT, you cannot use MP. The double negation of if W, then X. Well, you could use double negation on it and get rid of this to bring us W to X. Otherwise, that's all we can do. So that concludes Chapter 1, Section 4, Rules of Logical Reasoning. If you have any questions, send an email to my email on screen, and my office hours are also on screen. Thanks so much.